You recognize it. This is going to be partial fraction decomposition. So first, take it out of the integral. So x plus 2 squared. So these are both linear factors, right? So it's going to be an a over x minus a 3, a b over x plus 2, and then a c over an x plus 2 squared, because you're building up to that squared power. This one's the tricky one, so now I want to make sure you're being careful. You're multiplying both sides by this denominator. So let me write it in here. So I have x minus 3, x plus 2 squared, come back, x plus 2 squared. Okay, these denominators cancel, so I get x squared on the left-hand side. So be careful and think about how you're multiplying this through and canceling. So this times this, the x minus 3's cancel, so I just get that, plus, and when I multiply this times this, one of the x plus 2's cancels, and then when I multiply this times this, the x plus 2 squares cancel, so I get, c minus a 3. All right. This is where you always want to use your wise numbers. So I can see one of the wise numbers is x is equal to negative 2, because that makes this 0, right? So if I put x equal negative 2 over here, I get 4 equals, no, negative 4. That's 0. That's 0. Oh, well, you look at that. So I get c times negative 5. So c is negative 4 over 5. And just so I can make room, I'm just going to put it up here. Negative 4 over 5. Okay, because we'll be putting that back in. Then I want to pick another wise number. Another wise number would be 3. So let's do that. So x is equal to 3. So I get 9 equals, that's 0, that's 0. So I'll get 9 times 5. Oh, sorry about that. A times 5 squared. So that gives me a is equal to 9 over 25. All right, I'm going to put that one up here. A is 9 over 25. Here's the more tricky part where I need to compare coefficients to find the c. So let's think about where c is. I have c in front of an x term and a constant term. So this would be the tricky part here, is I have lots of x terms in there, right? Oh dear, what did I do? I put an a there, and that should be a b, correct? Yes, because that's what I'm trying to solve for. I'm trying to solve for that b. Okay, so now I'm going to even take the time to put in what I know. So I'm going to put in that the a is 9 over 25. 9 over 25, x squared plus 2 squared. It's the b I'm trying to solve for, right? But I'm going to multiply this out so I make sure I don't miss a term. X squared minus a 3x plus a 2x minus a 6, and then minus cx, plus cx, minus c times a 3. So if I was to look for the constant terms, let me rewrite that. C times 3 doesn't look like 3c. If I was to look at the constant terms, I think that might be the easiest. The constant terms on this side, aren't they 0? They are. And in this term right here, wouldn't I get, if I multiplied this out, the last term would be 4, right? And so I'd get 9 over 25 times a 4. And in here, I would get a negative 6 times a b. Don't I know what b is? No, I don't. Minus 6b. And then here, I would get a negative 3c. So that'd be negative 3 times this negative 4 over 5. Remember, fractions are your friends. We can do this. So I'm solving for b. So don't use your calculator to get decimals. It's just ugly. So let's see. So I have, I'm going to pull this over to the other side. So I have a negative 36 over 25 equals a negative 6b. And this would be a plus 12 over a 5, right? Subtract that over. And so negative 36 over 25, and if I want to make common denominators, I get a minus 60 over 25. So that gives me negative 6b, negative 6b. So that's negative 96 over 25 times a negative 1/6. The two negatives cancel. 96 divided by 6 is 16. So I get 16 over 25. Shoo! Okay, that took a lot of work. So let's see. If I put this back up here, 16 over 25. So B is 16 over 25. So all of those numbers you get to plug back in to here. So remember, you need to have this neatly written so you know where to plug it back into. And we do, so that's good. Okay, so A is 9 over 25. So 9 over 25. And I'm even going to pull it outside and make separate integrals right away. B is 16 over 25. This one right here, right? So I'd have 16 over 25, 1 over x plus 2. And then the C was negative 4 over 5. So I'd have a negative 4 over 5. And then a 1 over x plus 2 quantity squared. All right, almost done. So this gives me an easy ln guy. X minus 3, that's a 25, right? And then this is another easy ln guy. And this one here, you have to do it just an easy u substitution. And so that gives me a negative 4/5 u to the negative 2, right? You've done lots and lots of u substitutions, so you're comfortable with that. And then if you take that antiderivative, you get a negative 4/5, a negative 1 over a u, and the u is x plus 2. Plus a c, and then making sure to bring along everything else. 16 over 25, and then x plus 2. Shoo! Last one. So here I'm going to use tricky u, and I'm going to let u equal that whole numerator, including the radical. So then I get this, and then u squared minus 6 is equal to x. So now let's rewrite this. Let's think. It's going to give me a u. Oh, I forgot to take the derivative. Silly me. Can't forget that. 2 du is equal to dx. So little easy dx gets replaced with all of that, right? That's such a common mistake. And then the denominator is x, and that's this, u squared minus 6. I'm going to take the time to pull this 2 on the outside. So I get u over u squared minus 6. Oh, I'm sorry, u squared over u squared minus 6. What do I do with that? Oh, and just so you know, I don't think these answers match much, just there. So let's check it out. I think I need to do long division, or you can do your trick. Remember that subtract 6, add 6. So this could be u squared minus 6 over u squared minus 6 plus a 6 over u squared minus 6. So this gives you 1. So 2 times the integral of 1 plus, oh my goodness, what am I going to do with this? I think this one will be partial fractions. Oh goodness, it's not even a nice difference of squares, is it? Oh, I think I'm going to skip this one.